So hello everyone. So this is the third question from analog electronics, and here we have given this op-amp circuit with the capacitor connected across this negative feedback, and this capacitor is initially uncharged and op-amp is ideal. So first of all, we have to calculate the instant of time at which the op-amp switches from linear to saturation region. Means we have to find out up to which time instant the virtual ground concept on this circuit is valid, because negative feedback is present and virtual ground concept is valid at present in the circuit. So as the op-amp will enters into the saturation region, the virtual ground concept will not be valid there. And second is we have to find out the value of the capacitor voltage at this time instant, that is 2.5 millisecond. So because virtual ground concept is valid, it means यहाँ पर time will 10 volt है, and due to this 10 volt इस रेजिस्टर के क्रॉस ये 10 वोल्ट प्रेजेंट है. सो इट मींस यहाँ पर एक करंट फ्लो हो रहा है 10/1 किलो, दैट इज द 10 मिली एम्पियर. एंड बिकॉज द op amp is ideal, so यहाँ पर इंटरनली तो कोई करंट फ्लो होगा नहीं, सो दिस करंट विल सिंपली pass through this capacitor, right, the 10 milliampere, and this is the capacitor current because ये capacitor के क्रॉस फ्लो हो रहा है. And we can see that this capacitor current is IC, that is 10 milliampere, which is a constant current. And whenever a constant current जब flow होता है capacitor के cross, it means that capacitor is in the linear charging. This is the concept of linear charging. Whenever the capacitor current is constant, how it is linear charging? The capacitor voltage in terms of the capacitor current is written like this: 1/c integration over a time period t IC dt, and this capacitor value is 1 microfarad. So this will be 1 microfarad, which is equals to 10 raised to the minus of 6 farad. And यहाँ पर जो ये 10 milliampere है, it will be simply out of the integration because it's constant value, and dt the integration simply t. So this is the VCT, and we can see here that this is 10 raised to the power minus 2 or upon 10 raised to the power minus 6, so it is 10 raised to the power 4t. So this is how the capacitor voltage is directly proportional to the time. So that's why this is called the linear charging. Now due to this linear charging, we can see here the output voltage of this circuit V0 is depending on this capacitor voltage. How it is depending? If this output voltage is written like this, it means it is connected in this polarity plus minus of V0. And यहाँ पर इस तरह से we can see here, यहाँ से इस तरह से KVL we can perform the KVL यहाँ तक is 10 volt. So minus V0 plus VC and plus 10. So this is the KVL here. Minus V0 plus VC and plus 10 equal to 0. So V0 is equals to VC plus 10. So this is how the output voltage is linearly dependent on this capacitor voltage. And as the capacitor voltage is increasing due to the linear charging, so output voltage is also increasing. So now when this output voltage will reach to the saturation voltage, that is 15 volt, so the op amp will enter into the saturation region, because this is the concept. Whenever the output voltage op amp tries to exceed the saturation value, so the op amp comes in the saturation region and the output voltage is simply equals to 15 volt. So at that time instant, the op amp will switch from linear region to saturation region, and that value of time instant we have to calculate here. So we will simply equate this output voltage as 15 volt and is equals to, and the capacitor voltage in terms of time is 10 raised to the power 40 plus of 10 volt. So this is the 5 volt is equals to 10 raised to the power 40. This is the capacitor voltage, right? So when the output voltage has reached to 15 volt, means the saturated voltage, the capacitor voltage has charged up to the 5 volt, and the time instant is 0.5 millisecond. So at this time instant, the capacitor, the op amp has switched from linear region to saturation region, right? Now second, so first question, the answer of the first question is 0.5 millisecond. Now we have to calculate the value of the capacitor voltage at time instant 2.5 millisecond. So after this 2.5 millisecond, the op amp is in saturation region. So we can draw the circuit after 0.5 milliseconds. The circuit condition has changed and the circuit will look like this. This is the op-amp and this output voltage is equals to now 15 volt and the virtual ground concept is not valid now. So this is the capacitor and it is charged up to 5 volt. So we can write like this 5 volt. This is the VC and यहाँ पर ये basically 10 volt. Now this 10 volt will not copy because the virtual ground concept is not valid here because this is the saturated op-amp. This is the saturated op-amp and now internal current तो zero है, right? This is the 0 ampere current. So if we see the circuit यहाँ से लेकर यहाँ तक, if we see the circuit like this, इस तरह से यहाँ से इस तरह यहाँ तक का सर्किट अगर देखें तो we can see because ये दोनों सीरीज में है, because यहाँ से जो करंट फ्लो हो रहा है वो ही बेसिकली इस 1 किलो ओम के अंदर जा रहा होगा. So this circuit can be represented like this. This is the 15 volt output voltage and this is the capacitor and here it is the resistor of 1 kilo ohm. So this circuit, as we can see here, this is the 1 microfarad. So now we can clearly see that this is a basic series RC network, right? This is the basic series RC network in the charging mode because of this 15 volt. So this 15 volt is a constant voltage, right? Because the op-amp has entered in the saturation region, so the output voltage has saturated up to this constant value 15 volts. So it is acting as a DC supply to this network, and whenever capacitor के across एक DC voltage connected होता है, it means the capacitor now will charge इसके according. जो capacitor जो है वो now it will charge according to the transient concept. So transient के according अब charging होगी capacitor की. तो अभी तक तो it was linearly charging and now it will charge according to the transient concept. So we should have an idea about this transient equation of the capacitor voltage. So if I write the transient equation, first of all, if I am writing the standard transient equation, जो standard equation होता है VCT is like this. VCT is equals to VC of infinite plus of VC at some time instant, that is t0, plus minus of VC infinite and exponential raised to power minus of t0 divided by time constant. This equation is valid after the time instant t0. Now if the time instant t0 is equals to 0, then we write like this: VCT is equals to VC infinite plus VC 0 plus minus of VC infinite and exponential raised to power minus of t divided by time constant. This is the equation after t greater than 0. But this circuit that we have drawn here is after t greater than 0.5 millisecond. This circuit is valid after this time instant. So यहाँ पर ये सर्किट भी बेसिकली और आफ्टर t greater than 0.5 मिलीसेकंड. सो जो ट्रांजिएंट इक्वेशन होगा इस कैपेसिटर वोल्टेज का, वी विल राइट लाइक दिस. ये बेसिकली दिस इज द फाइनाइट स्विचिंग. ये जो ट्रांजिएंट इक्वेशन का फॉर्म है, दिस इज द फाइनाइट स्विचिंग बिकॉज यहाँ पर अदर देन 0 टाइम पर स्विचिंग हुई है, दैट इज द t0 टाइम. एंड यहाँ पर सर्किट की कंडीशन भी कुछ इसी तरह से है. सो VCT इज इक्वल टू VC ऑफ इनफाइनाइट प्लस ऑफ VC एट 0.5 प्लस minus of VC infinite because 0.5 second के बाद का सर्किट है and exponential raised to power t minus of 0.5 divided by time constant. This is the equation valid after the 0.5 millisecond. Now this VC infinite, when this is a basic series RC network, when the circuit is we have to, when we analyze the circuit at the steady state, so capacitor is open circuit. So जब ये ओपन सर्किट होगा तो सिंपली इसका ड्रॉप 0 वोल्ट हो जाएगा एंड VC इनफाइनाइट विल बी सिंपली इक्वल्स टू 15 वोल्ट, राइट. एंड एक सीरीज RC नेटवर्क का जो टाइम कांस्टेंट होता है, इट इज RC बिकॉज सिंगल resistor is present and single capacitor, so simply 1 microfarad into 1 kilo ohm, that is 1 millisecond. So यहाँ पर this is the value. So and 0.5 millisecond तक basically ये 5 volt के reach हुआ था. So this is nothing but the VC 0.5 plus because capacitor holds the voltage, so same voltage will be there. So VC infinite is 15 volt and plus this is VC 0.5 plus this is 5 volt minus of 15 and exponential raised to power minus of e minus 0.5 divided by time constant is 1. So it will be 15 minus 10 e raised to power minus of t minus 0.5 divided by 1. Now this is the equation we have got. Now we have to put the value of time instant, that is 2.5 millisecond, in this equation only. So we will, when we put the time instant value, that is 2.5 millisecond, so it will be 15 minus of 10 e raised to power. When you put the time instant, that is 2.5, 2.5 minus 0.5, that is 2, so e raised to power minus of 2. And this value is e raised to power minus 2 value होता है ये basically 0.1353 इस तरह ये value होता है. This is, so it will be 0.1353. So 10 से multiply करने के बाद it will be 1.353, and this answer will be, so 15 minus 1.353, it is 13.647 volt. So this is the value of the capacitor voltage at 2.5 millisecond. So now we can draw the waveform of this capacitor voltage like this. This is the, so this is the VCT, and this is the time instant in millisecond. So up to the 0.5 millisecond, it is linearly charging like this, यहाँ तक, so, and it has reached up to 5 up to this value, and यहाँ पर ये basically 0.5 millisecond. So this is the time instant, that is 0.5 millisecond, and it has reached up to 5 volt with a slope of, this is the slope, this was the slope of 10⁴. Now after this time, the capacitor has charged according to the transient equation, so it will be exponential charging. So because of this equation, ये जो equation है basically exponential charging equation, so it will be waveform जो है वो कुछ इस तरह से होगा, ये charge होता हुआ ऐसा, this will be like this, और ये final value पे इसका जो VC infinite पे जाके saturate हो जाएगा. This is the VC infinite, which is यहाँ पर जो ये VC infinite है, this is 15 volt, and we have to find out the value at 2.5 millisecond is 13.647. So कोई यहाँ पर lie करेगा, यहाँ पर we can draw like this, and this is the 2.5 millisecond time instant. So this is the time instant, 2.5 millisecond, and the capacitor has reached up to the voltage, that is 13.647 volt. So this is the capacitor voltage. ये basically maximum value है capacitor voltage, and this is the maximum value of capacitor voltage, and this is the voltage that we have got. So यहाँ तक तो capacitor was linearly charging. This was the linear charging of capacitor in this range, and यहाँ पर capacitor has switched into exponential charging. This is the exponential charging. So this is the waveform, and in fact this question that here is given, the instant of time at which the op-amp switches from linear to saturation region. So it can be asked in this form also, that the instant of time at which the capacitor is switching from linear charging to exponential charging. So both the form of the, it can be also the good form of question, right? So इस तरह से भी मतलब पूछा जा सकता है. So इस तरह से we can go. So this is the concept of this question. So okay, thank you.